This is the second part of a Level 2 Functional Skills Maths paper from NCFE. In this part, you can use a calculator. Activity 2, ice. Tom is studying science at college. He's learning about ice. Tom does an experiment. He shows the ratio of an ice cube's surface area to its volume affects the time it takes for the ice cube to melt. This scatter diagram shows his results. Tom has another ice cube. Each side is 2.5 centimeters long. Estimate how long this ice cube will take to melt. So we've got the dimensions, 2.5 centimeters long. Let's get the surface area of it. So if this is the cube, the dimensions would be 2.5 centimeters by 2.5 centimeters for each of the faces. And there are 6 faces which are identical. 6.25, so 6 times 6.25 equals 37.5 centimeters squared. So that's the surface area. As you can see, we've got to work out the ratio of surface area to volume. So we still need to work out the volume and then get the ratio. So what will the volume be? You know that it's length times width times height or depth. So we're going to go 2.5 times 2.5 times 2.5. Which gives us 15.625 centimeters cubed. So now we've got surface area 37.5 and volume 15.625. So we'll simplify this now, and looking at the two numbers, this is smaller. So to get that to be equal to 1, I'm going to divide both of the numbers by 15.625. So we get 2.421. Now that we've got the ratio, we're going to go and estimate. So 2.421 should be about here, because here would have 2.2, then 2.4, 2.6, 2.83. So what we're going to do first, though, is a line of best fit. Now, as you can see, there is a pattern here, and if we just draw a straight line as a line of best fit, it's not going to work. So we're going to have a curved line of best fit. Just try and do it in between the points. So something like this. Not perfect, but it gives the idea, and it can help us estimate. So going back to 2.421 and then going up This is where we end up. So roughly about 13 minutes. So we're going to write 13 minutes as our answer. In the science lab, Tom finds this mold for making 24 triangular prisms of ice. Draw a triangular prism. Let's start drawing. Actually, it might be better if we do it this way. So starting with the triangle. So these two lines should be parallel. And this line with this should be parallel. Doesn't need to be perfect, and it gives an idea. So this is a triangular prism. The triangular faces of each prism have base 3 centimeters and height 2.6 centimeters. Tom fills the hexagonal mold with water to a depth of 3.5 centimeters. Tom knows that to calculate the volume of each triangular prism, he can use the formula volume equals area of triangular face times depth of prism. When a volume of water freezes, the ice that is formed has a volume 4% more than the volume of the water. What will be the total volume of ice formed when all the water in the hexagonal mold freezes? So we'll need first to work out the volume of the water and then add 4%. Right, to get the volume of the water, we need to work out the area of the triangular face and then multiply it by depth, which is 3.5 centimeters. The area of the triangle is worked out by multiplying the base by height and then dividing by 2. So let's do that first. So 3 times 2.6 divided by 2. gives us 3.9. Now we multiply by the depth, which is 3.5. So 3.9 times 3.5 gives us 13.65. So this is just for one of the triangular prisms. And we've got to work out the volume of the ice formed when all the water in the hexagonal mold freezes. So that is 24 of them from the previous question. So there are 24 triangular prisms of ice. So that means we need to multiply this final answer by 24. So we'll do 24 times 13.65 gives us 327.6. So that is the volume for the water. Now we're going to work it out for when it's frozen. So that means adding 4% more. So working out 4%, 4 out of 100 times 327.6 gives us 13.104. Adding 327.6 and 13.104 gives us 340.704. And this should be the final answer. So writing it down. Icebergs are large lumps of ice that float in the sea. Tom reads that the icebergs float because the density of ice is less than the density of seawater. The density of ice is 0.90 grams per milliliter, and the density of the sea is 1.03 grams per milliliter. Calculate 0.92 as a percentage of 1.03. Give your answer as a percentage to the nearest whole number. So we're talking about 0.92 out of 1.03. Just plugging this into the calculator, in other words, doing 0.92 divided by 1.03, we get 0.893203 and so on. Now we've got to write this as a percentage, which means moving the decimal point 2 places to the right, a bit like the pennies in the pound. So this would be 80. Ted needs to pay £908.64 each month for his mortgage and other bills. This is 45% of his monthly income. What is Tech's monthly income? Give your answer to the nearest £10. So if we represent the 100% amount like this, which we don't know what is equal to, what we know though is that 45% is equal to £908.64. This is equal to 45%. So what we're going to do now is divide 908.64 by 45 so that we can work out the 1% amount, and then multiply it by 100 to get the full 100% amount. So I'm going to do 908.64 divided by 45 equals 20.192. Multiplied by 100 to get the full 100% amount. And this equals 2019.2. In terms of money, that would be £2019.20. So we've got to round the answer to the nearest £10. Here are the units, here are the tens. So we're going to decide whether we go for 2010 or 2020. And the 9 here tells us that we need to round up. So we're going to go to 2020. And that's the final answer. Jack needs to pay £908.64 each month for his mortgage and other bills. This is 45% of his monthly income. What is Jack's monthly income? Give your answer to the nearest £10. The manager of a small business claims that the mean salary in the company has gone up by over 10% in the last year. One of the workers says that the gap between the highest and lowest earners has more than doubled. Use this data about the company's salaries to decide whether each of the statements is true. Show your working. So we have two statements. One of them which says that the mean salary has gone up by over 10% in the last year, and we're going to look at that first. So what we're going to do is add the amounts for last year and divide by 12, and then add all the amounts for this year and divide by 14, and then compare the means. Adding last year's amounts, we get 457,260. Divide that by 12, and it gives us 38,105. Adding this year's amounts, we get 592,578 divided by 14, and that equals 42,327. Working out the difference between them, so 42,327 take away 38,105 gives us 4,222. So trying to work out the percentage increase, we go now 4,222 out of the original amount, which would be last year's amount, and that is 38,105, gives us 0.110799 and so on. So as a percentage, that would be moving the decimal point to 2 places to the right. So that is about 11%. Let's have a look. It has gone up by over 10% in the last year. That was the claim, and that is correct because 11 is greater than 10%. Now looking at the other statement, which says that the gap between the highest and the lowest earners has more than doubled. So let's find the lowest earner last year, and that is this. The highest earner is this one here. So working out the difference, 85,682, take away 15,275 gives us 70,407. Looking at the difference between the highest and the lowest amounts for this year, we have the lowest amount and the highest amount. So working out the difference again, 157,250, take away 15,500, and that gives us 141,750. The claim was that the difference has more than doubled. So if I double 70,407, let's see if that is lower than 141,750. And this is indeed lower than that. So the second claim is also correct. So both are correct. Dave is a salesman. He is paid a basic salary plus a bonus based on the sales he makes. Last year, Dave's bonus was 3/8 of his salary. Write 3/8 as a decimal and as a percentage. So if you input in the calculator 3/8 and then press the equals button, or do 3 divided by 8, you get 0.375, and that's how you write it as a decimal. Now, as a percentage, we've got to multiply this by 100 or move the decimal point 2 places to the right. So this becomes 37.5. Now I'll need to take off the decimal point in the decimal answer here, so I don't cause any confusion. Archaeology. Archaeologists study human history by digging up and analysing items from the past. Chen is a volunteer with the community archaeology group. At the weekends, she helps to dig at an archaeological site. The volunteers have to record exactly where each item is found. They do this by using a coordinate grid laid over a map of the site. The volunteers have found the wall of a building. It runs in a straight line from -125, 100 to 150, -75. Draw the position of the wall on the grid. So -125 first on the x-axis, and that is here, and it then goes up to 100. So that is the point. The other point is 150, which is here on the x-axis, and it goes down to -75. So that's -50, this is -100, and this is going to be in the middle. Now I will take off the other points. To avoid any confusion, and I'll join these 2 points up with a line. There is another way that the volunteers can record the position of an object, measure the object's distance from a fixed point, and measure the angle. See example in the diagram below. Volunteers find an object at the point 100, 100 on the coordinate grid. Mark the point on the grid in 4A. So let's go back to it. So point 100, 100. So that would be here. Moving on to the next step. The volunteers measure the distance of the object from the fixed point 0, 0, which is the origin. They then measure the angle. What size is the angle? Here is the point. And we're going to show the angle using a line. Now you could measure this with a protractor, but also this is half of 90 degrees. This is 90 degrees and this is half of it. So half of 90 degrees is 45 degrees. What size is the angle? 45 degrees. The volunteers find parts of a building. They think the building used to look like this. Draw the plan view and the side elevation of the building. Okay, so let's look at the building again from the top. So it looks something like this. So that should be what we see from here. And if I very quickly sketch that, it's going to be like this. So let's start drawing this now. We shouldn't worry about measurements because we're not given them, just to give a rough idea. On paper, this would be much easier with a ruler and a pencil. Let's double check. We need to also show these lines here. So something like so. But even if you do them as straight lines, it should be fine. So I'm going to add those bits in here. So that should be the plan view complete. Now the side elevation. Let's double check. That looks right. We don't need to include the windows. But if you want to, feel free to. Chen reads about some footprints that were preserved in volcanic ash. The foot length was 18.8 centimeters, and the stride length, which is the distance between the footprints, was 164.5 centimeters. Archaeologists use the formula R equals stride length divided by 4 times foot length. Chen uses a calculator to calculate R for the footprints found in the volcanic ash. She enters 164.5 divided by 4 times 18.8 and gets the answer 773.15. Explain what Chen has done wrong. So let's just first of all use the formula and substitute the values. So we've got R is equal to stride length is 164.5, and that should be divided by 4 times the foot length, which is 18.8. So basically 164.5 is divided by 4 times 18.8. So we've got to first work out 4 times 18.8. Which is 75.2. So Chen should have divided by 75.2, not by 4, and then multiplied by 18.8. If R is less than 2, the person was probably walking. If R is greater than 2.9, the person was probably running. If R is between 2.0 and 2.9, it is not possible to decide. Tick the correct statement about the person whose footprint were preserved in the volcanic ash. So let's go back to the previous answer. We said that they should have divided 164.5 by 75.2. So we're going to have to do that calculation. And with the calculator, that gives us 2.1875, which is in between 2.0 and 2.9. So we're going to say it's not possible to decide. Explain your choice. So we're going to say 2.1875 is in between 2.0 and 2.9. There are 10 volunteers in the community archaeology group. The probability that they all attend on a Saturday is 0.35. The probability that they all attend on a Sunday is 0.12. The site is open next weekend. Calculate the probability that all the volunteers will attend on both Saturday and Sunday next weekend. So we are looking at the probability that they attend on Saturday and Sunday. That means we need to use multiplication. So we get 0.35 times 0.12. Which is 0.042. We've got to give our answer as a percentage, so we're going to multiply this by 100 or move the decimal point 2 places to the right, which is going to give us 4.2%. The site was open on Saturday and Sunday for 26 weekends during last year. This table shows the number of days each volunteer attends out of the 52 days available. The information for Chen is missing. Chen says that the mode of the 9 values is 48. Is she correct? Explain your answer. So the mode is the most common value, the one that repeats itself. And looking at 48, how many 48s do we have? We have a 48 here, and that's the only one. So we can't say that the mode is 48 because there is only one value of 48. Similarly, there is only one value of 25 and 30, 24, and so on. So why do we single out the 48? So we are going to say that no, she's not correct. And as you can see, there is no mode, no other number repeats itself. So we're going to say no, there is no mode. The median number of days for the 10 volunteers, including Chen, was 33.5. What fraction of the days did Chen attend? Give the fraction in its simplest form. So 33.3 is the median. Let's see how that's going to help us work out the number of days for Chen. So if we put these numbers in order, we'd have, starting from the smallest, we'd have 18, 24, 25, 30, 35, 39, 40, 43, and 48. Now, if the median is equal to 33.5, the value should be somewhere in between 30 and 35. Because if you actually add 30 and 35 and divide by 2, that doesn't give us this median. So 33.5. So if I do 33.5 take away 30 to work out the difference, and then add that on top of 33.5 to see what number that would be that is higher than 30, and their midpoint would be 33.5, and see if that works. So that would give us 3.5 as the difference. So if I add 3.5 to 33.5, that would give us 37. But we have 35 before that, so that means it doesn't work this way. What we're going to do then, we're going to work out the difference between 35 and 33.5 and take away that difference from 33.5. So that 33.5 works out to be the midpoint between 35 and that number. So 35 take away 33.5 gives us 1.5. 33.5 take away 1.5 gives us 32. And that number sits in between 30 and 35, so it does work. So 32 is the value for Chen, the number of days. So what fraction of the days did she attend? That is 32 out of, how many were there possible? 52 days. So 32 out of 52, we need to write it in the simplest form. So dividing both numbers by 2, we get 16 over 26. Dividing again by 2, we get 8 over 13. And that's the fraction in its simplest form. And this is the end of the paper.